Hello, today we're going to be doing lesson 7.15, and our learning targets for today are that we can describe the effect on a scale copy when we use a scale factor that's greater than, less than, or equal to 1. We're also going to be able to explain how the scale factor that takes a figure A to its copy B is related to the scale factor that takes B to the figure A. So let's go ahead and see what we have here. All right. First thing, you can work with group members on this. So please let me know who are your group members. And if it's just you, that's fine. You just put that in there. Okay. So next, you have some cards here. And for each card, you have to find the scale factor from A to B. So why don't you take a minute to try that out on these and put them into the table. Okay, so I'm going to start with card 1 and 2 because they were a little bit easier than cards 3 and 4. So when I went to find my scale copy, I noticed that when we go from A to B, like for instance, this top line is 3, a length of 3, and then it changes to 6. And I know again, scale factor is what we multiply by. So I know 3 times 2 is 6. And then likewise, just to kind of double check it, to go from 2 to 4, these corresponding sides, again, we multiply by 2. So therefore, my scale factor for card 1 is 2. And luckily, we got the right thing here. So now I'm going to move to card 2. And again, I'm going to compare this little side here, which is going from 1 to 3. And I know that 1 times 3 is 3. And I double check that over here for corresponding lines. 4 to 12 is also times 3, so therefore my scale factor is 3. Now, I waited on these two because they really do get a little more trickier. Because notice, remember, there are all these diagonal lines. None of them match up on the actual grid lines. So all I'm going to do is take a distance from A and compare it to a corresponding distance on B. So it doesn't matter what that distance is as long as it's corresponding. Okay. So I think that I'm going to take this distance from where this little point goes and how it goes straight up to the tallest part of this one here. And as you can see, I went ahead and counted and I got a total of 6 for my length. And I'm just going to find the same exact length on B. So again, I started from this point here and I just went up to that tallest part. And here it's 1, 2, 3. So I know this length is 3. Again, it doesn't really matter what length you choose. You could have chosen how long across it is. As long as you're comparing the same thing, you're good. So since we already know that these are scaled copies, I really don't even have to do two different lengths. So I know to get from 6 to 3, it's dividing by 2, but I have to remember that scale factor is not what we divide by, it's what we multiply by. So I know that dividing by 2 is the same thing as multiplying by 1/2, because basically we're finding what half of 6 is. So that means for here, the answer is 1/2. You also could have put in 0.5 because that's the decimal version of 1/2. And finally, card 4, there's lots of different distances we could compare here as long as we're taking the same distance, right? So I'm just going to go ahead and take this one here. So this bottom line is 3, and here it's 1. So I know we're going from 3 to 1. So again, I'm thinking 3 times what equals 1. And since I don't, this isn't like a basic math fact. So remember, to undo multiplication, we just do division. So I know I take my answer here of 1, and I actually divide it by 3. And again, I'm choosing to write that as a fraction because I know fractions and division are the same. So this is actually the answer. This is the scale factor. We're multiplying by 1/3. So I'll go ahead and put that in for my answer. There we go. So now this is where you get to put into words what you did to find the scale factors. So try that out. Okay. So I wrote in again complete sentences and I used details in my writing to explain how I found the scale factors for all of these. So I didn't necessarily explain each and every one. I did them all together as kind of a whole. Now, the way I described this was that I first found coordinating sides on the scaled copies. And actually, now that I'm thinking about it, I didn't find coordinating sides here. So I'm going to say coordinating sides or coordinating distances on the scaled copies. Then I figured out what I had to multiply the original by to get the scaled copy. And that really describes exactly what they're asking. So let's try some different ones. Now we have to find the scale factor from A to B on these cards. So I've gone ahead and I just identified some coordinating sides, just like we did on the other ones, or coordinating distances, like this first one. And I've also identified the length of each of those sides or distances. So now I can find my scale copy. So now I'm thinking 2 times what equals 6? Well, I know 2 times 3 is 6, so that's got to be the scale factor there. On card 6, I'm going from 3 to 1. So now I'm thinking 3 times what equals 1. And again, that's not a basic fact, so I can use division. So I'm always going to take that answer and turn it into 1 divided by 3 to get that answer, which in fact becomes the answer, right? Because it's a fraction. Division is a fraction. So what do I multiply 3 by to get 1? 1/3. So I'll go ahead and type that in. Okay, now card 7. We're going from 6 to 3. So again, I'm thinking 6 times what is 3? And again, it's not a whole number. A lot of people want to say 2, but then you got to think to yourself, well, 6 times 2 is 12. It's not 3. So I'm going to take my answer of 3. I'm going to divide it by the factor I know, which is 6. And that actually gives us the answer even though it's not quite in lowest terms, which we can put into lowest terms, or you can put it into the answer key and it should work. But for this, this is something that you should be knowing is that 3, 6, if you divide both the 3 and the 6 by 3, you get 1/2. So the answer here, the scale factor is 1/2. Or you could also write 0.5 or 5/10. And finally, on this page, we're going from a scale, or I'm sorry, a length of 5 to a length of 5. So what do I multiply 5 by to get 5? 1. And if you notice, well, these are the same exact shapes. Nothing's actually changing. So our scale factor is 1. Okay. So next, let's see what we are doing here. We've got 3 more cards to go, and then we're going to kind of analyze all of the results that we got to see if we can make any conclusions. So again, find the scale factor for these 3 cards. All right, so I've gone ahead and completed this page in whole. And really, I did the same exact techniques that we were using on the other pages. On here, I found just any coordinating sides, right? So I did 3 times 2 to get this length. And you can check it on the other lengths. It's going to work out because this also is 3 and this is 6. So 3 times 2 is also 6. It should work out for everything. Now on card 10, I went ahead and just used the little side length. See, I don't like to count all these squares. So what I do is oftentimes if I know they're scaled copies, I just choose the easiest ones, the smaller sides, to try to come up with my scale factor. So if this was 1 and this is 3, I knew I had to do 1 times 3 to get my scale copy side here. Okay, so therefore my scale factor is 3. And then finally on this card, I knew I was going from 2 to 1. So I was trying to figure out what do I multiply by 2 to get 1? The answer is 1/2. So those are my scale factors. Okay, and we have 2 more cards. Go ahead and find those scale factors. Okay, so again, I identified some common or corresponding parts or distances. This is what I chose on these. Again, none of these lines were like on the grids, so I just chose a distance that I could count on both sides or both figures, and they're the same. So I know that the scale factor is 1. Also noticing that these look alike, which is kind of odd. Now, this shape, I was like, weird. We've looked at these two before, only it was backwards, and we went from B to A on the other one. So this time I thought, okay, we have to do 3 times what is 1. Well, in this case, remember, it's a multiplication fact. So to go backwards, we take our answer and we divide it by that factor. So we do 1 divided by 3, and that's actually our scale factor. It's 1/3. So that's what we multiply 3 by. And I put them in and they checked out. So now we actually know the scale factors of all of these. And we're going to sort those cards into 3 groups based on what we've already done. Okay. So you've actually done the hard work here. So go ahead and start sorting them. See, because some of them you're going to find the scale factor is less than 1. Others, the scale factors was greater than 1, and some of them were equal, right? So here's what we do. We're going to put these headers up like this. So we have greater than 1, equal to 1, and then I'm just moving these around, less than 1. So kind of go back and look at each card and look and see. So like card 1, we can go back and look. What was the scale factor for card 1? Card 1 was 2 and card 2 was 3. Well, those are both more than 1, right? They're going to go together. So I can come back to my card sort, and so I know card 1 was greater than, so I match it. And I also looked at card 2 and it was also greater than, so I'm going to plop that guy on there. Okay, and then you can kind of go back to each one and see what it was, right? See what you found. Was the actual scale factor greater, less, or equal to 1? So you finish matching these up and let's see what happens. All right, so I've gone ahead and finished my sorting. And um, before I move on, because in this next slide, it's going to say what will happen to the original shape if the scale factor is less than 1, greater than 1, and equal to 1. So we're actually going to come back and look at this to decide that, right? So I'm going to look at greater than 1. So in all of these, our original figure, the scale factor was greater than 1 when we went to the B figure. And if you take a look, and I'll kind of have to move this up so we can see it, it is part of this. I'm noticing they all have a pattern. When the scale factor is greater than 1, I'm noticing that the copy ends up being bigger than the original, right? Um, when I looked at when my scale factor was equal to 1, I noticed, well, they're actually the same. So the copy and the original are the same thing. Okay. And then finally, let's take a look at here. So in all of these, our scale factor was actually less than 1. So it was like a fraction form, right? And in each one, when we go from the original to its copy, it gets smaller, right? So the copy ends up being smaller than the original, right? So it's like if it's less than 1, the copy, or I'm sorry, the original shrinks. Okay. If it's the same, if the scale factor is 1, it stays the same size, right? And then if the scale factor is greater than 1, the original gets larger. Okay. And that's going to be true for any scale factor that's greater than 1, the same as 1, or less than 1. So let's see what we've got going on. Okay. So again, let's go ahead and take the time for you to type this in. You can pause. So the way I've described it is that if the scale factor is less than 1, the original shrinks and the copy is smaller. If the scale factor is greater than 1, the original gets larger and the copy is bigger. And if the scale factor is equal to 1, the original and the copy are the same size. So if we take a look at this, I know it's harder to see this. What's the relationship between the scale factor when you change the shape when you change which shape is the original. Okay. So what they're saying, remember how I said that before I saw that these two looked a lot alike? Let's go ahead and go back to those. Actually, if we can, we'll just go back to this card sort and we'll compare the two. I'm going to kind of move this around, even though I know that's not right. So we're basically looking at these two, right? So in this particular card, if we go back and look at our scale factor, the scale factor was 3, meaning we had to multiply all the side lengths of A by 3 to get to B, right? And when we switched it, right, so we switched the order, even though these have different letters, it's really like we went backwards, right? In this case, the scale factor was 1/3, okay? We also had that same situation going on for this card and this card, right? So if you kind of take a look, we went from A to B, and in that case, the scale factor was 2. If we were to go back and look at our chart, was 2, and this one was to same exact things, just opposite direction. The scale factor was 1/2. So what do we notice about that? If we're going back and forth from the same shapes but changing which one's the original, what are we noticing about the scale factor? Okay, and so what I'm going to do is to look more in depth at that. For this one, I would like to kind of notice that, when we went from A to B, we're multiplied by 3, right? So when we do this, we do times 3. Now, if we go back to our original thinking, like way before we knew about how to divide and how to change, find the scale factor, some of you might have said that if this was the original and it was 3 and then we went to 1, a lot of you would have said, oh, look, that's going from here to here is dividing by 3, right? Which, again, this is where we have to kind of go back to the whole thing with scale factors, not how we divide, it's how we multiply. So we know that to kind of undo what we're doing, we do the opposite. So if we want to undo dividing by 3, we have to times by 3. If we want to undo or go the opposite way of multiplying by 3, we divide by 3. But how do we change division into multiplication? Remember, dividing by 3 is the same thing as multiplying by its reciprocal, or 1/3, meaning 3 is a whole number, 3 over 1. If we find its reciprocal, we flip these numbers. So the reciprocal is 1 over 3. So when I look at my explanation here, I said, I noticed that if you want to go back and forth between two scale copies, you can either I should say multiply, divide by the same number. However, scale factor is only what we multiply by, which means that we multiply by the reciprocal. I knew I didn't spell that right. Reciprocal. I'll have to look that up. To go backwards, or to go back, whoops, to the copy. Okay. All right. So let's practice this. All right. So remember, given the scale factor from A to B, what's the scale factor from B to A? So they're literally giving us the scale factors, and we have to figure out what's it going backwards as. So if they give us the scale factor of 4, Remember, it's the same, that's multiplying by 4, right? So therefore, the it's the same as dividing by 4. Well, here, instead of multiplying by 4, you divide by 4, but that's not multiplying, right? And that's, you always use scale factors and multiplying. So I have to figure out what's the same as dividing by 4, but in multiplication. And so I need to erase that. I know that's 1/4, right? Because it's the reciprocal of 4. Okay. And then let's look at this one, 1/20th. Well, it would be the same thing as dividing by 1/20th, but I have to remember it's multiplication, and that means we're going to multiply by its reciprocal. So multiplying by, well, 20 over 1, which is actually just 20. Okay. This one's a little more tricky because, well, it's not with a 1 in the fraction, right? But it works the same. If this is our scale factor, it's the same thing as dividing by that number, which is really the same as multiplying by its reciprocal, which is 5/8. And this one's really tricky because it's a mixed number. So um, for this one, it's kind of like a challenge. I would first figure out what is this as a fraction so I can find the reciprocal, right? So 5 1/3, what that's saying is if I had 5 wholes and 1/3, how many thirds total is that? Well, every whole is 3/3, right? 3 pieces. So that means 5 wholes is the same thing as 15 thirds, but we got to add this one on, which is 16 thirds. So if I wanted to do the um, go back to its original, I really have to flip 16 thirds, and that becomes 3/16. Okay. So let's check those learning targets again. Let's make sure we hit everything. I can describe the effect on a scale copy when I use a scale factor that's greater than 1. Remember, that makes your original get bigger. If the scale copy is less than 1, it makes the original get smaller. And if it's equal to 1, it's going to stay the exact same size. We also can explain how the scale factor takes a figure A to copy B and how that's related if we go backwards and we do figure B to figure A. And remember, it's just going to be the reciprocal of whatever that factor was, the original scale factor. And that is lesson 5.